Hello, welcome to the Unlocking the Power of Greenhouse Environmental Controls webinar. We have a great presentation planned for you today, and we're excited to have you join us. I'm Janine Wright. I'm the Senior Communications Specialist at Prosmient, and joining me today is Paul Golden of Prosmient and Nick Earls of Wadsworth Control Systems. Before I tell you a little bit more about Nick and Paul, I just want to mention a couple of things. As we're going through the presentation, if you have any questions, please feel free to enter those into the chat or the question box. If they're relevant to what the presenters are talking about, we'll try and address them right there, then and there, and then we'll save any others for the last 10 to 15 minutes of the webinar. And also, you'll notice on your attachments, there is a PDF for you of today's presentation. So you have that for future reference, and that has both Nick and Paul's contact information on that. So if there's anything you want to follow up with from today's webinar, you'll know how to get a hold of them. So let me tell you a little bit more about Paul and Nick, and then we're going to turn the time over to them to give today's presentation. So Paul Golden is the sales manager for commercial growing at Prosmient. He has a lot of experience in floriculture, nursery markets and the retail markets, aquaculture, and the veg markets. Previously, Paul worked at Nexus Greenhouse Systems, which is now part of Prosmient, and he was the CEA engineer there, the Northern California sales rep, and the special projects engineer. So he has a wealth of experience to share. And Nick Earls is crop specialist at Wadsworth Control Systems. He has a hand in product designs, in technical customer support and sales there. Nick also has a lot of growing experience. When he was getting his bachelor at University of Arizona, he managed the hydroponic vegetable greenhouse there. He also worked at Denver Relief, managing their indoor cultivation facility, and was a head grower for a greenhouse in Pueblo, Colorado. So both Nick and Paul have a lot to share with you, and with that, I will turn the time over to them to add anything else they want to tell you about themselves and maybe mention a little bit about their companies, and we'll get going with the webinar. So Nick and Paul, it's all yours.
I'll let Nick go first since he's our guest today.
Thanks, Paul, and thanks everyone for joining. We're going to be going over a lot of different things today, but our main focus is really talking about greenhouse environmental controls. I'm sure a lot of you have heard of Wadsworth Controls. We've been around for a long time. Our main product lines are going to be control systems, custom control systems, curtain design, so energy curtains, shade curtains, light deprivation curtains, as well as vent automation. And I hope everything we can provide to you helps you out with the facility you have.
And my name is Paul Golden. I want to thank everyone for joining today. You may not have heard of Prosmient yet, but we've been around for quite some time now. We are the combinations of Nexus greenhouses, Rao Brothers greenhouses, and thermal energy greenhouses. So combined, we have over 150 years of experience in the greenhouse industry, and we serve everyone from the nursery and floriculture market to produce to institutional research and development greenhouses, as well as educational greenhouses and conservatories, as well as the box stores. So you've probably been in many of our greenhouses before if you've been to any of the bigger box stores chains. And in addition to that, we also support the cannabis industry. We supply greenhouses and indoor grow systems to the cannabis industry. So we're very active in all areas related to greenhouses. And with that said, I'm going to go ahead and start the presentation. So just a little overview about what we're going to talk about today. First, we're going to talk a little bit about using the different styles of controls, staged versus integrated controls, and the differences between the two, and what the proper applications for those different types of controls might be. Then we're going to talk about maximizing your irrigation and fertigation management systems. And then we're going to talk about embracing predictive controls. A lot of you might not know what that means yet, but we'll explain what that means. The customizing functionality of integrated controls, upgrading proactively and the importance to do so, as well as planning for future growth and scalability. And then lastly, we'll touch on some emerging trends that we're seeing in the industry. We'll go ahead and let Nick kick this off with the discussion about basic controls versus advanced controls.
Yeah, so there's a lot of different control systems out there. We're going to really, in the next few slides, we're going to talk about comparing thermostats versus stage controls versus integrated controls and what all that means. I'm sure you know what a thermostat is, but you might not know what the other options are. And then we'll talk about master integrated controls. So basically something that's, takes care of your whole facility compared to a single separate control option, which was something we do see quite often. And that's, having a controller for your irrigation, having a controller for your lights, having different controller for the climate. And now you just have a lot of different places you have to go. So it's nice to have it all under one roof or one control system. And then the different options that go with those control systems. So are you able to receive alarms and alerts, whether it be a text, a phone call, an email? Do you have access through your phone or through a VPN to the control system? These are all, really important things that everyone wants to use in a facility. I know we're all very tied to our phone nowadays. That's when you go to the airport, most people don't really print a ticket. You usually have that QR code on your phone. So that's kind of something that lives with us. And, if that's part of your business, you'd want to be able to access that from your phone. So we'll talk about these different options and really start with the basics and work our way up. So let's first talk about what are your first choices when it comes to a control system. So manual control, I don't even consider this an option, but it is something that's out there. We still have people out there rolling up their side vents and flipping switches to turn heaters on. Obviously, this isn't going to be a very effective way or efficient way to control your greenhouse. And with payroll being the most expensive cost of a business nowadays, you probably want to have, your employees working on something other than something that could be controlled very easily. So manual control is an option on there. I'd say the most popular thing I see when it comes to manual control still out there in the industry would be irrigation. And that is kind of one of the easiest things to add control to, where you could have increase in growth and increase in quality. And we'll really dive into irrigation and fertigation after we go through some of these options of control systems. So saying that, I would say the first option is thermostats. And some of you are probably, laughing over there saying, who uses thermostats? There's still a lot of customers out there that do. I'd say the biggest negative I see about thermostats is having multiple and having certain pieces of equipment being controlled, but actually forcing that air towards each one. So what I mean by that is you have a thermostat for a heater, a thermostat for an exhaust fan, and they're turning on at the same time because your air is getting mixed around and now you're heating and exhausting at the same time, which is definitely not beneficial to your energy bill or your climate. So thermostats, man, we replace quite a few of those still nowadays. And a lot of people are going into the next two stages, which is going to be the stage control and the integrated control. But yeah, there's just so many bad things. Thermostats, I know they're cheap. A lot of times when I go to a facility that has them, they have extras on the shelf. I don't consider thermostats a good option. I do consider thermostats a great option to have on the shelf as a backup if something was to happen to your control system. But you should also have backup parts that are, associated to the control system you have.
Yeah, I would certainly agree with you. I see a lot of thermostats not working in conjunction with each other. Obviously, there's no way to link multiple thermostats together, like you said, running different pieces of equipment. I think the only appropriate place I really think a thermostat has in these days in production settings would probably be in a more mild climate where you would see them in these cold frames, basically as just a holding area on the shoulder seasons of the year where you had the potential to get very hot inside this. When I say cold frame, I basically mean a passively heated and not really terribly cooled greenhouse. Sometimes you'll see a peak shutter and fan in those types of structures just to kind of take some of the humidity and heat out should you get into a warmer spring or fall day. But more often than not, those structures, either they don't have their coverings on them, they only have 1 year coverings during the summer months, or they don't have a crop in them during the summer months. So they're just really being used to protect against frost in a mild climate, and to be able to evacuate some humidity should the temperatures get up pretty high during the daytime. I used to have 13 ground to grounds, and they all ran on thermostats. Separate thermostats. None of them were accurate. I had no, they're all set to the same temperature set point, but you could walk in any house and it'd be a different temperature. The thermostats were terribly inaccurate. And then the other thing that used to always get me, I was out here in Colorado, and so we would use these houses in the spring and fall, and we can have 50-degree temperature swings here. And so we would manually roll up the sidewalls during the summer months, but during the winter, spring, and fall months, we would run a thermostat just for peak dehumidification and cooling. Well, what ends up happening here is a lot of times you'll have a beautiful week, and then all of a sudden you go into a cold week. And these thermostats are, they're set to cool the greenhouse at night, even at nighttime. Well, I might go from a 70-degree day to a 30-degree night pretty quickly. And it might be 6 o'clock in the evening, and we might be 75 degrees inside the house, which is completely acceptable. But I have the thermostat set at 70, and it's bringing in cold air. And it's going to basically, I should be trying to bank my heat in that greenhouse. And all I'm doing, because my thermostat has no control functionality other than set the set point and hope it works. Instead of banking that heat, I'm just spending it if I'm not there to turn it off.
Yeah. There's no way that thermostat knows it's 30 degrees outside right now.
Yeah, exactly. Exactly. Yeah. So I think thermostats are, the 20th century. We're in the 21st century, and you should be considering a more advanced controller in most cases.
I agree. No, but that was a good example, Paul, is like the cold frames that are like super low tech, not even tech almost, where those could have a benefit, because you're not going to need, if you got 2 pieces of equipment, you really don't need a full control system. You can and you will have benefits of it, but if you need to just kind of keep it low tech, sure, I guess that would be the one application that I can think of.
Yeah, again, if it would have had a day-night differential set point too, that might have been more useful. But
yeah.
Most thermostats don't operate that way,
No, they don't. So that's actually a great transition into the next option, or as we keep increasing our way along to more advanced controls, it would be the stage control. So actually right here in this picture is our step up model. It has 2 heating stages, 4 cooling stages. It can modulate a couple vents, and it can control energy curtain system. So very easy to use when you have a stage control. You're really just setting up your set point and setting up when different equipment is going to come on. And how that works is what we will get into next. So here's some examples. You can see some example pictures on the left side here. So basically a stage control is grouping equipment. So every greenhouse has a different design. It has different equipment that we're operating. So you might have 2 heaters in the greenhouse. You might have 6 heaters in the greenhouse. So we're going to group this equipment into these different heating and cooling stages and then have each stage with its own specific temperature set point. So you can see how if you had thermostats and you had 6 heaters, you'd have 6 thermostats, and that's not going to be very beneficial on how we're going to control things. So in this case, if we did have 6 heaters, we'd probably do 3 heaters. We'd probably do every other one to make it more of a uniform, distribution of heat throughout the greenhouse. But we would do, 1, 3, and 5 for the first stage of heating. And as that greenhouse started to get colder, because maybe it starts snowing outside, we can then turn on the next stage, which would be all 6 heaters. So there's some great example pictures on here. So as Janine mentioned, we do have the PDFs available in the attachments. You can be able to zoom in and kind of see some other options of how we're grouping and staging equipment. I would say, and we'll go over some more in the next slide here, because cooling usually has typically more equipment that we're going to be operating and grouping compared to heating.
And I will say with the stage controls, usually you're limited to only a certain number of stages, right? You can only do so
you
much.
are.
And usually that's the same. If you're lucky enough to have a stage control that could do multiple zones, it's going to be the same stage settings, or not settings necessarily, but the same stages for all those different zones, because that's how the controller is set up.
That's correct. And a lot of the stage controls, great point, are usually a single zone option.
Yeah.
There's not really a lot of, I don't even know if there is a multi-zone stage control out there. Because the other thing that you're limited in, besides just heating and cooling stages, is the amount of sensors you have. So a lot of times we're just looking at climate, and that's really what a stage control is. So as I mentioned earlier, when we're looking to add irrigation and add more features of controlling a curtain system or adding CO2 or grow lights, that's not going to fall into that category of a stage control. But a stage control does have great applications. So we see a lot of these in garden centers, veggie growers, lots of middle school, high school 4-H, setups, because they're very easy to use. And if you're just trying to control the climate, they work perfect.
They're really popular with your box store retailers, and that's because in most cases those guys are landlocked. They're not going to expand. They're not going to add additional equipment. They've kind of got a single purpose for that structure. Sometimes it's only seasonal, even the use of that facility. So they don't need to go overboard with controls. But yeah, and then again, they don't have that many advanced stages of controls either. So so we kind of talked a little bit about the heating. Let's go ahead and move on to some examples of what the cooling might look like in a stage control system. So, typically you'll have anywhere from 3 to 4 stages of cooling, maybe even a 5th stage, which wouldn't be impacting the cooling equipment as much as the light levels in the greenhouse. But this is a representative example of what could either be a produce or an R&D institutional type of greenhouse, or even a cannabis facility where it has some of the common equipment we would see in a greenhouse. We have an intake vent. In this case here, it's up in the roof, in the corridor of the greenhouse. We have an evaporative pad wall in that corridor as well. We'll have mixing fans inside the zone. We'll have shade curtain systems inside the zone. And then we'll have any number of exhaust fans appropriately sized for the ventilation of the space. And what we would typically see is a first stage of cooling, and this is oftentimes referred to also as your dehumidification stage. It's an incremental opening of a roof vent or an intake vent, whatever it may be. In this case, 33%. And then we turn on a single exhaust fan just to be able to move a small volume of air slowly, because it could still be very cold outside, and we don't want to shock the crop. We move a small volume of air slowly through the greenhouse, and because the exhaust fans aren't pulling a very large amount of air, we keep the HAFs on just so we have a proper amount of mixing. So this control setting knows that between a certain temperature, let's just say 72 to 75 degrees, that this is the equipment it would keep on. And once it goes beyond 75 degrees, it would switch into stage 2, and it would be a whole nother algorithm for the controller where it would be turning on now 2 exhaust fans, and then also opening up the roof vent a little bit more so we're not choking those exhaust fans. Should we not be able to hit the temperature goals under stage 2 cooling, what we could do is we could turn on all exhaust fans and open up the intake to its maximum entirely, so that we can bring in as much air as possible through the greenhouse. Now, if the temperature outside is warmer than the temperature inside, we're not going to get below we're not going to get to our desired set point, whatever the temperature inside may be. So that's when we would go to the 4th stage of cooling. And what it would do here is it would turn on all exhaust fans as well as the pad wall. And then you can also have your shade curtain system involved as well. That might be considered a 5th stage potentially of cooling, where the shade curtain would close to help reduce. Let's just say you're doing everything you possibly can. The pad wall is working to its maximum capacity to cool the greenhouse. You're using all your exhaust fans. You just can't get the greenhouse cool enough. Now the only option you have is to reduce the light levels, which is usually the last thing you want to do, depending on the crop. If you have a high light loving crop, the last thing you want to do is close the shade curtain if you're exceeding your temperature levels inside the house. So that's a pretty representative example of how I'd say most garden centers these days operate, most research facilities operate. A good number of cannabis growers throughout the country in the proper climate would operate the facilities like this. And any, obviously any production greenhouse that's not passive would operate in a very similar fashion as well.
Yeah, no, great point. And I'd like to say that, this is just an example based on this equipment of how we would stage everything or group the equipment together. This is going to change depending on where you live. So I grew vegetables hydroponically in Arizona. We're not going to have the evap wet wall be the last stage. It's so dry and so hot. We're going to move that up towards the front. Okay. So maybe probably cooling stage 2. So a lot of this design that we put into these control systems is really based on the crop you're growing, the equipment that you have in your geographic location. So these are all discussions that you should be having with, your greenhouse designer or control system company so that they can make sure that they pre-design it for what you're looking for. So, yeah, and another point, just because we were comparing thermostats a minute ago to the stage control is, if you look at cooling stage 1, we're opening the vent a certain percent and turning on exhaust fan. Well, when we do that in a control system, the control knows what percent that vent is open before we turn that exhaust fan on. So if it gets really hot really quick, it's not going to just turn the fan on. It's going to wait for that vent to open. And if that was controlled by a thermostat, you might be causing a negative pressure in that house and damaging your structure or damaging that vent from even opening.
Yeah.
So
burning up your motors. Yeah, absolutely.
Yeah, burning up motors. Yeah. So on that note, when do you take the next step? Okay. So when are you going to look into an integrated control? So integrated control is basically a way of controlling equipment, not in a group, but individually. So we're taking all the equipment you have, and sure, we can group a couple exhaust fans together and control them together if you'd like, or you could have it all separate. It's all going to just depend on, how many outputs you have available with that control. And before we dive into this kind of list that we have here of equipment, and it continues on, is I like to kind of talk about with a control system, what's an output and what's an input. So it's just like a computer. An input, we're taking in a reading from a sensor, and we're telling an output, a piece of equipment, what to do. So when you're looking at a control system, you definitely want to find out how many inputs and how many outputs are available with the system, okay? So an integrated control is a lot more precise because we can control everything individually. You have more sensor options available. You can graph a lot of this stuff into more detail than a stage control because, again, we're just looking at temperature, sometimes humidity, and we can control a lot more equipment. So lights, irrigation, misting, CO2, because those are items that you could put in those stage groups because it wouldn't make sense based on climate. Don't you agree, Paul?
Yeah, I would agree with that. The big thing here, I think, the differentiator between the very rudimentary controls and your integrated controls is really data. I mean, at the end of the day, you can collect data with some of the stage controls. Many stage controls offer that. Some of them don't offer that in a very friendly manner. But now you have data for how each piece of equipment's running inside the greenhouse. You can really dial in on how it's operating. You don't get anything with the thermostat. Yeah. Some stage controls offer it, some don't. But with the integrated controls, you have the functionality to use each piece of equipment the way you want to. Now they may be banked together, like we might have multiple unit heaters banked together, multiple exhaust fans banked together, as Nick mentioned. But you're getting the functionality of a greenhouse that's able to use all of its equipment in harmony the way that you want to use it. Yeah,
and you might change how you control that based on different seasons compared to a stage control where you're really just adjusting your goal or your set point. You could also adjust, when those stages come on, but it's definitely going to be a huge difference with an integrated control, especially when I think of like CO2 is, you're not going to want to be dosing CO2 when the exhaust fans are on. So if you had a separate CO2 controller and then you had your stage controller, you might just be wasting that right out the exhaust. So
exactly. You have the ability to control much more equipment because, well, first of all, the controller is designed for. Oftentimes, it has some algorithms in place for the different type of equipment that an older, more rudimentary control system might not have. And that might be a good segue into the next slide to kind of discuss what are some of the options that we can control. With with integrated controls. You want to speak to this, Nick?
Yeah, sure. I'd love to jump in on this one. So dimmable grow lights, I'd say one of the most new, popular, and I say new, they've been around for many years now, but there's not many lighting companies now that are not coming out with their new lights all dim, just because of the functionality. And we're going to talk about grow lights in another slide, but having that option available is definitely going to save you on energy usage and dial in the intensity that's coming to the crop. VFD fans, that's going to be variable speed fans. Another really popular thing we've seen in the greenhouse industry. So we talked about staging controls and having different exhaust fans come on at different stages. Integrated controls, we can obviously turn on exhaust fan 1, have a different set point for 2. But the variable speed is really nice because we're able to slowly ramp up the RPMs of that fan so that we can just give enough cooling and then turn it back off or ramp it back down. So this helps with any overshooting because we don't want to cool too much and now the air mixes and now we're going into our heating stage. But this just allows it to dial it in a lot easier. Okay.
Far fewer cyclings, right? There's no cycling.
Yeah, no
cycling. It might turn off, but it's not going to be cycling up and down probably all day. I'm sorry, it's not going to be cycling on and off all day. It probably more or less is cycling up and down, but keeping the temperature steady or the humidity steady or the pressure steady, whatever it is you're trying to do.
Yeah, and compared to turning on an exhaust fan all the way and pulling 12 amps of power and turning on a variable speed that might be just drawing 3 amps right now because it doesn't need the full speed on. So definitely a lot of benefits. The other one I really like actually is the paddle fans. So if you have like a passively ventilated greenhouse, so you have roof vents and side vents, this is something Prospient does all the time, which I think is wonderful, is those actually spin both directions. So say it's winter time, and these fans are similar to like a ceiling fan that spins with the blades, is say it's winter time and the heat rises, you can blow that air right back, that heat down towards the crop. But in the summertime when it's really warm and you're pulling your cold air in through the side, now you can spin the fan and blow the air up through the roof vent and get the heat out. So kind of a cool feature that I feel like a lot of people don't know about, And then it kind of moves into the next 3 bullets of chillers, air conditioners, and kind of boilers as well. This is something we see in like sealed greenhouses, very high-tech research facilities, certain cannabis facilities, certain crops that really have to have it dialed into a specific temperature no matter what's going on outside. And these items like a chiller system, and really in my mind, boilers, can't be something that's controlled by a stage control. You could jerry rig some things to happen, but there's a lot of moving parts. There's modulating valves, there's fans. You got to have temp probes in front of the hot coil and the cool coil to determine what's going on, and that will also help you with dehumidification. So it can be very efficient, but some of these can be a little bit more expensive on the upfront cost, but you're going to want to have a good control that can take care of that. And we have
two systems. That's one of the ones we see all the time. People running separate controls with no coordination of equipment between them whatsoever. This is a very common theme here with CO2. It's becoming more common to use CO2 too, especially when you talk about your large produce facilities. A lot of times today, when we build a facility that has either semi-sealed or sealed, meaning we're using HVAC and dehumidification air handler units. A lot of times what we're trying to do is we're actually trying to recover the CO2 off the boilers and inject that into the house. And you really can't do that with the type of standalone control systems that they have out there. That would be separate from the rest of the greenhouse. It has to be part of the overall integrated greenhouse control.
Absolutely. Yeah. Yeah, and then the other few things we have on here, so curtain systems, I consider like energy curtains just a standard nowadays. It's actually pretty rare for a facility not to have an energy curtain, so something that helps trap the heat down towards your crop so you're not heating that attic space. Obviously, this is also going to help with shading and reducing light level if you have a young crop in there, but having control that can do all these different features depending on what's going on in your house, outside your house, you need an integrated control for that.
Absolutely. It's becoming, like you said, it's more of a standard these days. It used to be a luxury.
Yeah.
now it's more of a standard or a requirement. A lot of places are calling for light abatement. So maybe you're not growing a crop that requires photo period control, but we might have to put blackout in there just because you're next to an airstrip or a neighborhood. And then the other thing that we're seeing much more often too is multiple curtains, curtain on top of a curtain, or double curtains or triple curtains. And older control systems really didn't have much place for that. They really didn't. They had a hard enough time just modulating anything, let alone running multiple modulated outputs.
Yeah. No, great. That's a great point. Yeah. And when Paul says multiple curtain systems, just throw it out there. They usually have different types of fabric involved. So some could be open weave, closed weave, different shade percentages, blackout. So that's what he's referring to. Next ones would be irrigation, fertigation. I'd say the number one thing I see is people with their Rainbird Hunter controller mounted on the wall, and they got a different controller controlling the rest of the greenhouse. Does it work? Yeah, sure, it does work. It's usually limited on how many valves you control and how you can trigger an irrigation event. How long does that controller also last? I know I was just on the phone with someone the other day, and they have a bunch of those, and they use them in the field also, and they get struck by lightning all the time. So they have boxes and boxes of these things on the shelf. But on that note, I think this leads us nicely into the irrigation fertigation aspect. So I'll go ahead and start on this one here. So irrigation and fertigation, again, I say irrigation is the number one thing. I still see people hand watering, and it's so easy to overwater one pot and then the next pot underwater, and just not having the uniformity there. That's really where irrigation comes into play. Fertigation becomes a big benefit because of having, recipe creation. So something can mix whatever recipe you're going for. And you might have a greenhouse that has different crops growing, which is very common. You have one greenhouse that's doing poinsettias, the next greenhouse is doing mums, the next one is doing shrubs, and you have different nutrient profiles for all of these. So having a fertigation system that can do multiple recipes where you can input it into the controller and have different notes on it, different stages of growth, and all that saved in it, so it can make it easy to go to that next crop or go to the next stage. I do want to touch on when it comes to fertigation. So the one here in the picture is an H.E. Anderson J+ Advanced system. It's an inline blending. So what that means is it mixes the nutrients with the water in line in a chamber and injects the amount that needs to be in there. It also is reading through pH and EC sensors what is going in there, and it's also looking at the flow rate. So it determines how much it injects based on the flow rate going by of water. So this is a very popular way to do it. And you could do this with dosatrons as well. That's also an inline blending method. The next option would be a batch tank system. And they all have their applications. A batch tank system can be a little tricky sometimes based on what nutrients you're doing, but it fills up a chamber with water. It enters in certain nutrient inputs. It mixes up the water. It adds pH adjustment, so acid or base, to try to get to where it needs to be. Then it might add some more water if EC is too high, and it fills up a tank, and then you have your recipe. Sometimes issues can happen, though, where if certain nutrients are concentrated too much, they can fall out of your recipe and basically solidify to the bottom of the tank. But you just have to do that properly. The next option is a holding tank, and that's kind of like inline blending. So you inline blend, you fill up a tank, and you distribute your fully mixed nutrient recipe from that tank to other places. Okay, and we could have a conversation about all three of these for hours.
That could be their own topic, yeah.
And same with the next one is synthetic versus organic nutrients. I'm not going to touch on what's better, what's worse, but I wanted to put it in there just because when you're picking your fertigation unit, you need to have the company aware of what type of nutrient you're going to use. So an organic nutrient can be a lot thicker. You might need to make sure you have the proper pump head that could pump that. And you also need to make sure that you have a system that might be able to flush out your lines so you're not getting any biofilm or buildup and clogging drip emitters. So just some things to keep in mind while you're picking the design for your facility.
I think the biggest thing here too is when we talk about these modern day inline systems versus the old style of I'll just say a dummy machine that's a pumper or doser, that doesn't really collect any data. It might have an instantaneous readout, but it's a separate standalone machine that's not collecting anything. It's hard to go back and gauge what it was you were doing last season or last crop or last rotation, whatever it might have been. With those old rudimentary systems, we still go into greenhouses all the time and see those types of systems which have no link to the climate control system, so they're not working in unison with them most times. And then in addition, they just don't have. There's no ability to really monitor that system.
Yeah,
you have the real time reading, but other than that, you don't have much.
Yeah, no, I agree. And the other, some other big factors is definitely mass irrigation valve control. You can see in the picture, there's quite a few valves right there. We have customers with over 100 irrigation valves, and you're not going to be able to do that properly from your Rainbird controller. And some of you out there might say, oh, well, we got 20 Rainbird controllers and we're doing it. Well, another issue that can happen is you might be running too many valves at once and you're not actually getting the proper amount of water to your crop because your flow rates have dropped. So you would need an integrated control to say, hey, I can run a max of 3 irrigation valves at once to get the right amount of water over. Okay, so that's another spot where that integrated control is going to come into play. We are seeing a lot of people now reading their runoff. So after the water runs through the soil or media in the pot and seeing, what you're getting. And sometimes that's getting filtered and reintroduced at a certain percent back into the system. And Paul, I know you've probably dealt with this quite often.
Yeah, well, certainly, yeah, it gets reintroduced at a lower rate, obviously, just so you're not sending bad salts back into the system. You're, more often than not, what you're trying to do is you're trying to conserve water in this case. You've probably used a decent amount of the nutrients that were in it in the first pass, and then the second pass, what you were going to do is you're going to dilute the runoff, clean it. First of all, clean it, and then dilute it, and then send it back in. There's, we have the capability to monitor all that these days. The other thing I think that's really interesting about the way that we can pair and group zone valves together is now we have the flexibility, not just, let's just say we're doing a drain to waste kind of system. We have the flexibility now to flush the entire zone before putting a new crop in there, or between switching different stages of crop growth, or maybe we have multiple stages of crop growth in the same zone using the same header lines. Now we have the ability to clean those lines out so that we're not shocking a young crop with the highly concentrated nutrients that we use on a let's say a stock plant that was right next to it.
Yeah, no, and actually that brings up another point. I have a customer that they actually use a low concentrated plant friendly cleaner that they dose through their fertigation system, and they run it for just a little bit before they're going to irrigate, because they want to make sure that it helps clean the drip emitters out before they then send their nutrient recipe to the plants. So that's kind of their style to make sure there's no issues and those are all cleaned and not clogging. So you can really only do that with an integrated.
It'd be pretty manual if you did it the other way around.
Yeah, it would.
Tough. You'd be sitting there making adjustments. The other thing, we've all been there before. Anyone that's irrigated something manually before has been there, where you've left something on too long and flooded the greenhouse, or you just went through the entire 55-gallon drum of nutrients because you forgot to turn it off and it just flushed it into some space, or it wasn't properly set. There's no way to really put alarms on those kind of systems, right? Hey, it's been on for 2 days. Well, you left on Friday and forgot to turn it off, and now it's Monday morning and you're completely out of all your nutrients and the crop's ruined.
Yep. Yeah, I think we've all done that. At least left a hose on, So, and actually that transitions us perfectly into talking about what sensors are available when it comes to nutrients, irrigation, fertilization. So I mentioned that fertigation skid that we were just looking at had flow sensors, EC, pH, but we also want to see what's going on at the crop. So this right here in this picture is our soil analyzer at Wadsworth. So this is a really popular sensor in the system, or in this industry now, and it basically does soil temperature, soil EC, and soil moisture content. So you probably see VWC on there, so volumetric water content, seeing how much water is in that media or soil. And that could be a big benefit because you can look at data like Paul mentioned before. You could see if you're overwatering, if you're not, underwatering because you saw plants wilting, what was the percentage reading on the sensor, and really just help dial things in. Another, huge benefit is that overwatering part. So maybe you have it scheduled to water every day for 5 minutes, for example. Now you can say, hey, well, maybe it was a really cloudy day outside and we went to go ahead and do our normal watering, but it says that there's too much moisture in the pot. Now you could go ahead and skip that event. You're not overwatering. You're still getting proper root growth. You're not getting root rot. And you can do all that by using your control system and the sensors that are available to you. I do have a few other sensors listed. I put soil pH because there are some good quality handheld soil pH sensors out there. I don't feel there is a good soil pH sensor that's connected to an integrated control yet. So I really hope, we find one at some point. We've done a lot of testing on that and some of the NPK sensors for soil that could be linked to the system. But a lot of those manufacturers that have come up with that still don't even recommend utilizing that data yet. So that is something that I hope when we have a tech talk next time, we can actually say something like that is available.
Yeah. Well, the NPK sensors that I've seen out there, what I've learned about them so far is it seemed to be that their calibration doesn't last terribly long, so they're more of a consumable. They're out there, they're available. I don't know very many people that are really tying them in with controls and dosing at this point. I think it's more of just a spot check, but that is something I think that will be emerging in the near future.
I agree. I can't wait for that day.
Flow sensors. I mean, we use flow sensors all the time. These are critical for knowing whether you have pump down or any number of issues you might run into there. So that's a commonality that I see across multiple irrigation systems for sure. Yeah,
I agree. And I did just put PAR on there just because when I grew in Arizona, we actually triggered a lot of irrigation vents based on accumulated light, so moles of light in the day. Arizona being a really, really bright place and warm, we could actually trigger it based on if it was really sunny out. How sunny was it? So that's another option that you could utilize with a control system that's not going to be available with your traditional, Home Depot residential irrigation controller.
Probably more appropriate for somebody that's doing a monocrop or something. The same type of crop. But yes, it's a very, very powerful tool because if you just have a basic timer irrigation system, you're going to be wasting water and probably slowing down crop growth. If you're not needing
it. So let's talk about embracing predictive control. As Paul mentioned, you probably don't know what I'm even talking about when I say that. But a lot of the control systems are getting more advanced nowadays. So you could kind of look at outdoor conditions. So you can see this greenhouse here, this Prospient greenhouse with the Wadsworth weather station on there. Most greenhouse controls now have a weather station. So if it gets too windy or starts raining, or obviously if it's snowing, you're going to want to close your roof vents or protect the structure. We don't want a gust of wind coming in the roof vent, lifting that roof vent right off and having troubles. Or if it's an open roof greenhouse, we don't want the rain coming down onto the crop inside there. And that's where the weather station would take care of it. Well, I think a lot of us live in areas where that happens quickly. As Paul mentioned, he could have a 50-degree difference in Colorado. So one of the things that we can do with predictive is we have predictive weather. We can say, hey, at 2 o'clock, it's supposed to have 40-mile-an-hour winds. So maybe at 1 o'clock, we want to automatically close those roof vents and protect the crop and the structure. So utilizing your control system and some of these new features to take care of it. Another one I have on here is the boiler. You don't want your boiler running all day, but as outdoor temperature starts to drop, then you could start having your boiler start to turn on and get up to heat before you start needing to use it. Yeah. All right, customized functionality. Most controls nowadays have, options to control different types of greenhouses, different types of equipment. Obviously, a passive ventilated greenhouse, roof vents, side vents, is going to have a lot different equipment than a closed greenhouse with chillers and boilers and all that. So you need to pick the right control system, and that's really what we've been trying to talk to you about, is find what's the best for you, your crop, your company, your design. And most of the time, the greenhouse company like Prospian is going to work with you to figure out what's the best solution for you. And they'll have that designed properly because they've been doing it for so long. But you need to really look at, seasonal settings that can be saved into the system, saving plant growth stages, having options for backup generators that can trigger pieces of equipment. Because I know we do a lot of projects in greenhouses that are in the middle of nowhere, and they might have a lot of issues when it comes to losing power every once in a while. And so backup generator in those cases can be a must. What do you think about that, Paul?
Yeah, no, that's a great point you bring up there, Nick. We have, first of all, every facility really should have a backup generator. If you're using it year round, you should have one, because if you have a valuable crop in there, you run the risk of losing your entire crop in a matter of, 15, 20 minutes on a very hot day or a freezing cold day, potentially. So you're running an extreme risk by not having a backup generator, but sizing a backup generator can be pretty challenging, right? You have a multi-acre facility with, let's just say, 500 lights in it.
Yeah.
You're not going to want to size that facility. You're not going to want to size the generator so that it's running all those lights. Lighting is not a critical element every minute of the day. You can have it. You can go a day or two without the proper light levels and still recover. So what we do is we see a lot of load shedding in the control system itself, and we can program any individual piece of equipment not to turn on during a power outing event or when we're running the backup generator. The other nice thing about this is we have alarms for everything. You would know should you lose power, what's going on. You would also know should the houses go outside your set point, should the zones go outside your set point. You'd usually get an alarm right away to your phone or to your email saying, hey, you need to go look at your greenhouse before too long, or else you're going to run into troubles.
Yeah. So this is another subject we could talk about forever, is looking at your data and looking at graphing. And, we've been doing controls for a long time. And I'm one of those people that goes on site a lot of times and tests it and trains the customer on how to use the control. We go over a lot of stuff and looking at graphing. And sometimes we might come back, and some of those facilities have never used it. They just don't. They're like, hey, the climate looks perfect. I don't need to use the graphing. Well, I'd say in the last, 8 years of doing this, we have seen a huge increase in the growers actually utilizing their data and graphing. Because one, we're trying to create the best product. We're trying to create more product in that same house. And we're trying to reduce the amount of energy consumption that we have in the greenhouse. And really the only way to do that is if you have a good graphing program. So you can't really see this graph too well, but I'm looking at, heating and cooling equipment. I'm seeing when it's turning on and off. I'm looking at indoor and outdoor temperatures as well as humidity. And I can utilize this information to be able to dial in my facility for whatever I'm trying to do,
Yeah, the data, and we're going to get into this when we talk a little bit about emerging trends, but the data is really where everyone's moving towards.
Everyone.
It's critical to business decisions, operational decisions, and as we start to link more and more data across different pieces of equipment and different, eventually we even start linking production data to climate data. Now you really start to understand where you're getting the most bang for your buck in your investment and how you spend your operational capital.
Yeah, no, I agree. I think linking harvest data to climate data has been one of the big things I've seen a lot lately, and labor as well.
Labor, exactly.
So we'll talk a little bit about lights. I don't want to take up too much time on lighting, but using your control system to be able to control dimmable lights and putting a light sensor or a PAR sensor down at your crop and have those lights modulate a certain percent on and off based on what the sun is providing. It is supplemental lighting, so we don't want those lights on all the time. There are a lot of lights out there nowadays. Most of them are dimmable. You can kind of see in this picture here, we have LEDs in one bay and double-ended HPS in the other. These are, definitely options for both of them to be dimmable, but we have seen a lot of people starting to transition from those HPS to the LEDs, as you see right here in this picture. The other thing that people are looking at is DLI, so daily light interval. So looking at how many moles of light has your crop received that day. So I think lettuce is like, we're looking at a lettuce picture. I think it's about 16 moles per day.
Yeah.
So, yeah. So once you hit that 16 moles, turn those lights off. Don't leave them on. Let's save that energy from the lights creating heat and cooling the greenhouse down, but mainly the lighting just using as much power as it does. You also want the option to be able to dim down the lights if the temperature gets too warm. Again, that's not something a timer mounted on a wall can do. That's going to be something your integrated control can do. And we're also starting to see spectrum tuning. So being able to change and have light recipes based on the crop that you're growing and what you want to do. So especially research. So let's talk a little bit on, I always say, let's upgrade proactively instead of reactively. Wadsworth Controls have been in business since 1952. So we got lots of old controls out there. And, it's great that they're still running. That's, we like to make a product that lasts. But a lot of times there's not going to be replacement parts, or there's limited parts, or if your system goes down because you've had it for so long, that we might have to make a new control system, and that usually isn't an on-the-shelf product. We got to make it custom for your facility, like we've been talking about. So that could take a few weeks or even a few months. So making sure that you're planning to upgrade before an issue happens with your current control is something I highly recommend doing. I always kind of explain it in the fact that none of you have pagers. No one has a pager anymore. So even if that pager still worked, would you even use it? It's time to upgrade. So if you got some old controllers out there, or some old pagers, if you will, let's get you into like a new iPhone or Android or the new controls. I'll let you take this one.
No worries.
Deal with this a lot.
Yeah, exactly. So, I think the other thing here is when you think about if you're thinking about putting up your first greenhouse, or you're thinking about putting up a new greenhouse at a new site, the desire for going with an integrated control, one of the major desires for going with an integrated control, is the ability to expand on the input-output modules that control would have. And so the ability to go to a multi-zone functionality, so to have more, you could gutter connect a separate greenhouse to your existing facility. And if you already have one of these existing integrated controls, chances are you could probably just simply add another panel and run that greenhouse, that new greenhouse or that new zone off the same controller. So scalability and growth is kind of something that we have to think about when you're choosing the control system. As I mentioned before, if you're just a single box store and you're not going to, you're not going to expand, and you're not going to expand because you can't, you're right up against it, you're landlocked, then maybe you don't need a more advanced control that has the capability to add additional input and outputs down the road. But the other thing that I have to say is, most people don't consider all the changes in technology taking place over time. So, you could have types of equipment that you'd want to bring in 10 years from now, but if you maxed out your simple stage controller, chances are, first of all, there's probably not an algorithm to run that type of equipment. But additionally, you might not even have the ability to add additional inputs and outputs to that stage control system. So I think the type of controller definitely has to hinge around what your growth strategy is. And if you're not going to ever grow, maybe stage controls will be fine for you. I still wouldn't recommend thermostats, but if you plan on growing, which most people do, then you should probably be considering these integrated controls.
Yeah.
And then some emerging trends here that we want to talk about is, first of all, tying in automation with the control system. We've already seen this to a large degree inside the greenhouse, not just climate automation, but actually like growing systems automation, transporting plants and cleaning pieces of equipment and stuff like that. We would have all the tracking plants, scanning plants, all that is something that we're going to start seeing more and more often. Tracking labor data too with a certain crop, and of course tracking all the inputs. Now that we can actually monitor and record how frequently certain pieces of equipment are being ran, we can tie that to, we can imply what the energy usage or water usage or natural gas usage would be when those pieces of equipment are being run, just based off of run hours. Supplemental lighting, the ability to dim, load shed, that's a big deal too. We're going to start seeing more and more when with energy prices in certain places, pockets of the country, we see more large growers that have supplemental lighting or have boiler systems or have high energy demands for different pieces of equipment. If they can get away with load shedding during certain times of the year because of the time of day use pricing of energy is so expensive, or let's just say the power plant needs it to heat houses. It needs the gas to heat houses, and you have to shed your boiler for that time being. Well, there's ongoing abilities to do something like that.
Yeah.
HVAC systems are becoming extremely. I'm sorry, Nick. You want to say
something?
something?
I was just going to say, yeah, utilizing your off-peak hours. So
yeah, exactly. Especially for things like DLI, right?
Yeah.
You can't really necessarily do that with heat so well, but you can do that with DLI. You need the heat usually.
Yeah.
But and obviously energy curtains and the use of them, being able to use multiple energy curtains, that's becoming more of a standard now. One of the best marginal ROIs you could do. I would say controls are also in that category. If you're spending money, if you're wasting running equipment, wasting energy, wasting water, wasting other feedstocks into the system, by getting everything under one controller and having it coordinating its functionality amongst different pieces of equipment, that's definitely a major ROI for you guys. HVAC systems are becoming more and more common. HVAC and dehumidification systems are becoming more and more common in all styles of greenhouse production, whether it be R&D, whether it be cannabis production, whether it be veggies. We see a lot. I don't think we see it too much in the floriculture nursery industry still yet, but it's very common with veggies to be semi-sealed, and to be able to run a 4-pipe system. A lot of people might not understand what that means. It's a hot water line going in, a hot water line going out of the unit, air handler unit, a cold water pipe going in, and a cold water pipe going out. What this allows you to do is heat, cool, and dehumidify all with the same system. And we're seeing that these types of systems are being adopted more and more, because even though running electricity to chill a greenhouse through cold water systems can be pretty expensive, there's times of the year when you could stay semi-sealed and make a lot of gains on your overall energy bill. Plus, you're not just throwing your CO2 away. That allows you to increase productivity. So anytime you can increase productivity, oftentimes you can also put a little bit more into the cost of operation too.
And I think about IPM as well. If you have a sealed greenhouse, sure, you could have thrip screen that's going to help, but if it's fully sealed, you have I mean, a lot less possibility of having an issue in your greenhouse from outdoor pests and bugs and all that stuff. So mildews and molds as well.
Another emerging trend that we see, I don't think we put it on here, is the ability to remote access. That's something we already have in most of our controllers. Some of them have different platforms where you have to do it on a cloud-based, or some of them have apps, and some of them you have to do it on your computer and log in. But being able to remote access from all around the world, really, and see what your greenhouse is doing and make adjustments to it in real time is something that's, I wouldn't say so much an emerging trend. It's already there. That's more of a standard these days.
Yeah, and I know we've done a lot with people that have our cloud access with our seed controller. Is they might have questions on something, they might be adding more irrigation valves, they might just want us to look at graphing data for them, and they can actually go onto their cloud and allow tech support access for X amount of hours, and that allows us to remote in. So like I was doing a chiller and boiler system, and they just implemented it, and I was able to watch it overnight and see how the valves are reacting to the temperature that was in the climate, and make small adjustments to help fine tune the facility.
So great point about that fine tuning. And I think always when I think about that fine tuning, I think about your labor and who has access to that fine tuning, and how, and what are they allowed to fine tune? Today's controllers, integrated controllers, many of them have an ability for you to log in using a unique identification code, so that we know who made the changes, what changes they made, and you can give people different levels of administrative rights. So some people might have an ability to just irrigate, where others have the ability to change the climate change the climate settings, or even more advanced settings than that even.
Yeah, no, we didn't even talk about that. That is very, very important. I call that the finger pointing software.
Yeah, we're not just tracking data for what's going on inside the climate, but we're also tracking data on how the controller is being used by its users.
Yeah.
So some of the other things we've seen there's been a lot of discussion about AI and machine learning. It's going to certainly happen one day. Some control systems are capable of doing various degrees of that right now, but it comes down to data. Data is what drives the brains behind this. Just like we talk about these large language learning models and how they're able to work to create poems and songs and whatever that kids are using to cheat on college exams. We need the data to be able to drive that technology. And so, but one day there will be controllers out there where you literally plug them in, and you give it a basic a set point where you want to be, where you think you want to be, because you haven't even collected any harvest data yet, where you think you want to be. And the controller itself will look at the entire spectrum of equipment that's available there. Will make the decisions as to how to. It'll basically experiment, make the decisions on how to ultimately keep that climate the way you want it to be. And then once you actually start having the harvest data, the machine itself will start being responsive to your set points and say, you really don't want to be at that set point. If you just increase this by 5 degrees, we can either get more productivity out of this zone, or we'll use less energy, whatever it is that you're trying to optimize to. And then the other thing that's kind of a subset of that is one day there will be, and there's already a lot of organizations working on this. It's just, no one's, I would say there's an industry leader. Yeah, one day there will be a capability to maybe a drone or a sensor in the sky inside the greenhouse and up in the ceiling of the greenhouse. They'll be able to look at your entire crop and identify, based off of large amounts of data, problems ahead before the human eye could ever do that, whether it be mold or insect infiltration or whatever it may be, root rot or something that's something you can't just pick out with your eye right away. It's collecting so many data points, and it knows a good plant from a bad plant, and will be able to tell you that you have a problem, and maybe even make an adjustment for you.
Yeah, and there's some people going into that. Iunu looks like a little typo there. Iunu is a company that's using cameras to look at nutrient deficiencies and mildews and molds, using cameras on track systems in greenhouses. So I think that people are starting to get their foot in the door, like you're saying, but then to be able to link all that data to go to your control system to make calculated responses based on that information is going to be really neat when that happens one day. So,
and then wireless sensors. These are, to a degree, they're already out there, but they're, I don't particularly know of anyone that's the leader in the industry, but they're available, and I imagine most control systems would have a shot at being able to integrate them right now. But I think when I think about wireless sensors and where these really pay off is your large production growers. When you have this huge acreage of, they could be very rudimentary greenhouses, but huge acreage of crops, and having to run all that wire, from house to house to house just to control one basic thing. And the other thing is when you run long distances of wire, oftentimes the readings become less accurate.
That's true. And I think the big thing with wireless sensors, the big main word I would say is quality. They've been around for a while, but the quality of sensors, I feel like we're just starting to see them.